Hey guys, it's Mrs. Dugan. Today we're going to go over some notes while I'm out, okay? So you should have two pieces of paper. You should have one that's already glued into your Gus. It should look like this. It says forces up at the top. Oops, wrong way. There you go. Okay, this is what we are going to fill out first, and then we're filling out this one right here, which you picked up from the door, okay? If you don't have the first sheet of paper, I only have a couple extras, so you need to write this stuff down in your Gus, okay? So, first thing, we talked about forces. Forces. A force is a push or a pull on an object, okay? So, forces are really important because they are how things move. Remember, it changes its shape. Forces change an object's shape. It changes the direction, it changes the speed, and it changes the way that it's moving. It can cause motion or it can stop motion. Okay? Now, okay, what is a contact force? We have two types of forces. So think about football. Football is a contact sport. That means things are touching. So definition of a contact force is a force exerted on an object when the two objects are touching. That means they actually have to be in contact with each other. Okay. Examples of this are friction and applied force. All right. So we talked about friction. There are four types of friction. There's rolling, static, sliding, and fluid. If you don't remember which ones those are, you need to look back at your notes from Friday where we talked about them. It is on this page right here. That page right there talks about friction right here. Okay. Then we have non-contact. So if contact is that they're touching, non-contact means that they are not touching. And these are forces that we don't necessarily feel pressing down. Okay. Examples of that are gravity, magnetism, and electricity. We're really only going to focus on gravity and magnetism in seventh grade, specifically gravity today. All right. So again, this is kind of review. Okay. So forces have two things. They have strength or magnitude and direction. So when we are representing forces in a diagram, we're always going to use arrows. And these arrows, the length of the arrow is going to show the strength. How strong is this arrow? If it's a longer arrow, that means that it's going to have more strength. If it has a shorter arrow, that means less strength. The direction the arrow points is going to show the direction of the force. So if it's pointing down, that means the force is being pushed down. Now, here's an example. So, oh, that didn't work. Well, there were supposed to be two arrows there. So if there were two arrows here, let me just draw it real fast. If I had a really long arrow here and a really short arrow right here, okay, which one's going to have more strength? Well, it's the longer arrow because the longer the arrow, the more strength it has. The SI unit for forces is always the Newton, named after Sir Isaac Newton. Now we're getting into this page right here. Okay, gravity. Now, gravity, when we think about gravity, most of the times we think about it being a force that keeps us on the earth. However, gravity is something even more than that. If we look at the definition is the attractive force between any two objects that have mass. All right. So, what is mass? When we think about mass, when we think about weight, when we step on a scale or we are weighing something at the grocery store, that is actually the mass. Mass is the amount of matter in an object. Okay. Mass doesn't change. We don't get to, if we go to Mars, the amount of matter that we're made up of doesn't change. Okay. Our weight changes. Weight is gravity in relation to mass. Okay. So when I talk about mass, I want you to think about stepping on a scale. Okay. And in science, we measure mass with kilograms. So again, gravity is how attracted two objects are together. When we go out into space, yes, it's not gravity we're not thinking about gravity being pushed down, trying to get us to push down somewhere. It's actually two planets coming together. Gravity is the reason why we're circling the sun. Okay, gravity is the reason why the asteroid belt happens. It's why we have a moon, because these objects are going to be attracted to each other. So the two things that are going to affect the strength of gravity or affect the gravitational force are mass, how big something is, and distance, how close together it is. When you have a really large mass, think about the sun. It has eight eight planets, excluding Pluto. It has 8 planets circling it. That's how much gravitational force it has. Okay. So as you get closer and closer to the sun, you're going to get pulled closer and closer. So that's why Mars is so close. It's got a small mass. It's not very big, but it's so close to it that it's going to grab hold of it and it's going to be in the sun's orbit. Okay, so mass, if it has a large mass, it's going to have a really big gravitational pull. If it has a large distance, if it has a small distance, if something is close together, if they're close together, it's going to have a large gravitational force as well. And we'll talk about more of it in a second. So if we look at our marbles, they're all the same distance away from each other. Which one is going to have more gravitational force? Well, that's number three. Three. Why? Because it has more mass. They're bigger. So they're going to be more attracted to each other. All right. Now, which set of marbles will have the least gravitational force? Well, it's number one because they have less mass. All right. So think about it this way: Pluto and Mars. Okay. They're going to have less gravitational pull towards each other because they're smaller. All right. Compared to the sun and Jupiter. Now, we're going to get into distance. Okay. Distance, if it has more distance, if it's farther away, it's going to have less gravitational pull. Okay. More distance, less gravitational. It's an inverse relationship, meaning that if I increase my distance, if they get farther away, my gravitational force decreases. Okay. If I decrease the distance, that means that the gravitational force is going to increase. So in this case, which cowboy hat has the greatest gravitational force? Well, which ones are the closest? That is going to be number one. They're closer together. Now, they're all the same size, so distance really does matter. If the gravitational force, which one has less gravitational force? Well, that's number three because they're farther apart. The big takeaway here, okay? When mass increases, gravitational force also increases. So if something gets bigger, its gravitational force is also going to get bigger. When distance increases, if they get farther away, the gravitational force is going to decrease. So it's an inverse relationship. As one goes up, the other goes down. Okay. Now, this is really important to understand. When you have things, how do I say this? Distance has a greater pull than mass. Think about Jupiter. Jupiter and the sun are not close together. Okay. Jupiter's orbit is not like Mars where it's following closely. Okay. If you are closer to an object, you are going to have more gravitational pull than if you were larger and farther away. Okay. Distance trumps everything. It doesn't matter about mass. If it's closer, it's going to have more gravitational pull than if it's farther away. Okay. Distance trumps everything. And we'll get into some application questions tomorrow, and we'll get really dig into it over the next couple of days. But this right here is the biggest takeaway. When mass increases, gravitational force increases. When distance increases, gravitational force decreases. All right, so that's it for all of our notes. Okay, now I'm going to explain to you about about this right here. Okay. So what you're going to do is you're going to go into Schoology, okay? And Schoology is going to show you a gravitational simulation, all right? And this gravity simulation is going to really help you understand how gravity works, okay? And how mass and distance impacts gravity. So you need to follow the instructions. Let me say this one more time. Follow the instructions. It says to increase the mass. You need to increase the mass. If it says to decrease the mass, decrease the mass. You need to look at the arrows to see what happens on the force. Okay, and I'll put up another video in case you get confused. All right. Good luck. I'll see y'all later.